Welcome to setting up a hybrid Kubernetes cluster using Calico CNI provider episode. As you may know, Kubernetes supports Windows nodes with some limitations. In the previous episode, we set up a hybrid Kubernetes cluster using Flannel. And if you recall, if you watched the video, you noticed that you may remember that we had some severe limitations. So in this episode, we're going to evaluate Calico. And actually, I really like Calico. I just tell you up front, it works really well. So I'm going to remove the other one with Flannel because that really is not going to work very well in the current form. Hopefully they improve that. In this episode, we are going to set up the same cluster, but we will be using Calico instead of Flannel. Before describing the installation process, let's talk about prerequisite dependencies and nodes. First one is Windows masters are not supported. This means that we'll need to set up a Linux Kubernetes cluster first, and then join our Windows nodes to it. The second note is additional components must be installed to support Windows Worker node. So be prepared. It's a little bit more involved than setting up a purely Linux-based Kubernetes cluster. And the last one is not all Calico modes are supported. We are limited to BGP without encapsulation or VXLAN. So BGP stands for Border Gateway Protocol, and Calico takes advantage of this protocol and enables the nodes, both Windows and Linux, to exchange route information. And that's how information or the communication between the pods happen. The other method is VXLAN. And VXLAN is useful when you have your nodes on different clusters. I'm not going to go through the in-depth discussion of BGP and VXLAN. It's beyond this course, but I have another course entitled Understanding Kubernetes Networking, Part 3, Calico Kubernetes CNI provider in depth. So in that, I go into very detailed discussion of all of this, especially BGP and how we set up our cluster. For this demo, I'm going to use BGP without encapsulation because I have all my nodes, both Linux and Windows, are all on the same subnet. So that will work really well for us. But again, if you're in a situation where you have your one or more nodes on a different subnet, then you're forced to use VXLAN. Okay, next we are going to the terminal and actually start setting up our cluster. So let's take a look at the script that needs to be run in order to set up our cluster first, and then things that we need to do to ensure that the cluster is ready to accept a Windows node. We need to do some prep work here. And make sure also that as you go through this script, it makes it a lot easier for you if you also have your Windows node ready, and you need to have Windows Server 2019 version 2004. So again, Windows Server 2019 version 2004, and versions are very important. As we mentioned in the intro, Windows containers are very particular in the versioning. So you have to make sure that all the versions match. Okay, so the first section of this script, we need to run that on all Linux servers, and basically what it does, it sets up everything, all the requirements such as containerd for container management, and also Kubernetes itself. So that will install those. And then if you scroll down, once that's completed, then in this section, it says that the section should be run only on master. So basically in this section, we set up the cluster we initialize, so on line 54, sudo qadm init. And when you run that will initialize the cluster, and then you get this command here at the end, kubeadm join. Once everything's successful, we get this command. And if you have more than one Linux server that you want, aside from the master, you need to run this command on all those nodes to join the cluster. Okay, let's go scroll down. And then you also need to create a folder called, hidden folder called cube in your home directory. And then you need to copy the config file from this location to that location, and also set the appropriate folder security. And then on line 61, you will need to install Calico, and you need to download it from there, and then run the kubectl apply -f and the YAML file. You just download that, and then that will set up Calico. And then we need to copy this content of the cube folder. There was just a hidden folder cube. We need to copy it to all other nodes that we set up, either on Linux or on Windows. So we need to be copying those to the home directory, either on Linux. So this is Linux, and this is Windows, equivalent on Windows. And that is needed when you want to install kubectl to interact with the server. You need those certificates in the right place, and that's the location I need to copy to. Also, after that's done, then you need to create on your Windows, you need to create a folder called C or K under the C directory, under the C folder, and that's where the installation of Calico on Windows expects that folder needs to exist. So exist either you do it either through a command from SSH from Linux, or you can do it on Windows. Either way, you must have that folder ready. And then this is very important. You need to again copy the config file from the cube folder to this folder. So you need to copy in two locations on Windows. One is in the home directory up here, and also to this CK folder. So this K folder and the C directory. So that's as far as kind of getting everything ready in this section. So again, on Linux, if you have more than one server, you need to then SSH into that, and then run this command on kubeadm and join them. And if you don't have any other Linux server other than the master, you can ignore this section. And then we go to this right there. So go ahead and set everything up as we discussed. Make sure you have your cluster ready set up, and then we'll go through the code, the following code here to set up, to prepare our cluster to accept Windows node. Okay, hopefully by now you have your cluster set up. So in this section, we're going to make some changes to Calico in order to be compatible with Windows. So the first thing that we need to do is download Calico Ctl, and to make sure that we can access it from anywhere on the machine, we need to change the directory to a folder which is on the path. So the user local bin is on the path. So, but that requires a sudo login. So let's go ahead and change to sudo, and then change folder to that. And then we're going to download the Calico Ctl CLI, so we can then communicate with Calico setup. And then on line 94, we set execution permission, and then we exit sudo. And then in this section, we're going to disable IP and IP, because as we mentioned in the section in the intro, IP and IP is not supported on Windows. So we need to download this setting and change the setting on there. So let's go ahead and open that file. And the setting that we need to change is right here, IP mode. You need to set it to never. Okay, and then on line 100, we need to apply that. So Calico Ctl apply -f and that file name. The next thing that we need to do is we need to, although we set the IP mode to false on the Calico side, on Kubernetes side, I've noticed that that change is not reflected, so we need to set that manually also. And the reason for this is as we run the script to install Calico on Windows, it will, during this installation, I noticed it checks for this configuration. And if the value of IP and IP enabled is set to true, it fails. And so we need to set that manually. So let's go ahead and do that. And then open that file again to modify. And we go to the end. Here it says IP enabled. We need to set that to false. And then on line 104, we're going to apply that, and that's done. The last thing that we need to do is we need to set another Calico configuration, that is Calico Ctl IPAM config. The setting is strict affinity true. And this is required because this allows that the Linux Calico nodes to borrow IPs from Windows. It's a long discussion, but for now, just just remember to run this also. So that's set. And then to make sure everything works, we're going to reboot the machine. And then once that's completed, then we'll concentrate on the Windows side. Okay, now let's concentrate on the Windows side, on the Windows node, and see what needs to be installed and how to prepare the node. The first thing that I suggest is disable firewalls, and this is of course, for testing and getting everything set up. This is not appropriate by no means to do that in production, but during development, if you want to set up your cluster and do some testing, I would say the last thing that you want to worry about is ports. So turn everything off on the Windows side. And then the next section is we need to install Windows containers and Docker itself. So this section, you can go through the commands here. The first one is we install containers, then we need to restart the machine, then install the Docker provider for the PowerShell Docker provider module, and then we install Docker here, and then we restart again. And then last thing is we set the service, the Docker service, to start up always, so automatically start. The next section is we need to install additional Windows network-related components such as remote access and routing. So those are the part that also needs to be added, and every time that you see this restart reboot, so you need, so it require quite a few of rebooting in order to get everything set up on the. Once you do that, I'm not going to go through all this. You can do it on your own. But when we get to install Calico, this is a section that we're going through. We're going to go together. The first thing that you need to make sure is that if you recall, we created a folder called K on the C folder. If you forgot to do that, then you need to do that right now, because otherwise you won't be able to proceed, because everything will fail. That the installation process that we'll talk about that right here, it assumes that there is a folder called K under the C directory. And then another reminder, if you did not copy the config file from your home directory .cube to the K folder. You need that now before proceeding. If you miss any of this above, then the installation is going to fail. So hopefully you get everything done and prepared. And so pause here and go again, double check to make sure everything on this side, make sure everything is set up. Also make sure that you created this folder and you copied the config file. So hopefully once all that done, then you can go ahead now and actually download the script that will install Calico on Windows. So that is on line 37. So go ahead and download that. That's done. Now on line 39, and so we are going to install that PowerShell module or file that was downloaded, and then we're going to pass in the version of Kubernetes that we're going to install. For this, I'm going to install version 1.20 because I installed Windows Server 2019 version 2004, and that is compatible with Kubernetes version 1.20. So let's go ahead and run that, and it's start downloading stuff and downloading. It takes a few minutes, so just be patient with that. And then I'm going to pause here and then continue once that's completed. So once that's completed, you may get this waiting for Calico to finish, and then you see nothing happens. Everything's okay. What happens is that when Calico installs all this stuff, it also installs a virtual switch or vSwitch. And once it does that, it actually, the connection between the server, the VM, and the terminal that you're running from, it's get disconnected. So in this case, I was SSHing into the server, and then that was kind of hang. So you need to exit that, either close that terminal and create a new one, or if you are remote desktoping to it, you might have lost the connection. But all you need is just reconnect, the established connection. So I'm going to log back in. Okay, and then we continue. So we need to make sure that these two services, that is Calico Node and Calico Felix, are running. And we'll see that that one is running. And for Felix, it says that stop. So we need to make sure we start the service. So from here, I can do it. And then the name of it is Calico Felix. Just go ahead, copy and paste it here. Okay, so double check that again. And we see that it's running. So make sure that those two services are running. Now we need to install, download, and run kubelet, kubeproxy. Those are required because that's how Calico is going to actually join this node to the other node, to the master. So let's go ahead and download that. So that's done. Now I'm going to start the service. And start the service too. Okay, so at this time everything should be set up now. The last thing that I suggest is Calico, as part of the download installation, it downloads the kubelet, kubeproxy in Cube Ctl. It download them put them under K in the K folder. I just want to move it, copy it to a folder which is in the Windows path. So when you issue kubectl command, then you can run it from anywhere. So I'm just going to copy that there, those there. Okay, so everything is now set up. Now next, we're going to verify and do some testing. So before getting into the demos, I kind of beefed up our cluster. I added one additional Linux and one additional Windows node. So we have now a master and 2 Linux nodes and 2 Windows nodes. So once you learn how to set up the Linux or Windows nodes, then the process is the same. You can set up as many as you need. So let's do some testing now. The first thing that we want to do is verify our cluster. So on line 57, kubectl get nodes -oy when we run this. So we get the same information that I just showed you in the slide. So now we have a more beefed up cluster. We have a master, 2 Linux, these 2 are Linux, and these 2 are Windows node. So let's go ahead and clear that. We can also verify our BGP cluster. If you recall from the presentation portion, Calico sets up BGP in order to for the nodes to exchange route information. So I'm going to switch to now to the master because BGP or the Calico CLI is installed on our master node. So I'm going to run the command on line 60, sudo Calico node status. So when you run that, so this is now a view of our BGP, and these are all the servers. So this is from the point of view of a master, it's peering with these all other nodes. So these are the IP addresses of both the Windows and Linux clusters, Windows, and some information. And the important thing is they're all established, which means that our BGP cluster is up and running. And as you can note, that says no IP6 peers found because everything we are running right now, we are internal, so we're just running on IPv4. So let's say go ahead, clear that, and then switch back to the Windows node. Now we want to deploy a test application on line 63, kubectl apply -f, and this is the YAML file that we're going to execute. So take a look at the content of the YAML file. The YAML file contains instructions both for the service declaration and also for deployment. So let's take a look at deployment first. As usual, we label and name the service. And then under spec replicas, that is the number of pods that will be part of this deployment, 2. So there will be 2 pods part of this deployment. And the selectors match labels. And this is the label that any pod that matches this label will be considered part of this deployment. And the template, so this is the template for the pod. So this is the label Web API app service, and we name it the same thing. And their spec, this is the spec for the containers, and then where it's coming from, and this image is coming from the Docker Hub. I created a very simple Web API application that we'll be using as part of this testing. And the node selector, this is very important when you, for deploying Windows application, you need to have this node selector, and this is the name of that label that needs to match. So all the Windows nodes will be added this node. So we can take a look at them by looking at a kubectl describe node and the name of the node. So this is one of the Windows nodes. When we run this, it gives a lot of information. So kubectl is one of the great commands of kubectl or Kubernetes that you can get a lot of information about any object that you are dealing with. So in this case, we have the name. So this is the name of the server that we specified here. And these are the labels. So there are various labels that have been added, but this is the one which we are concerned about. This is exactly as this. So all the Windows servers, Windows nodes will be added this label. And the reason for this is if we don't specify this, the Kubernetes will may schedule this deployment on Linux node, which is not good. Obviously not going to work. And then and there's servers. Again, you have the name, the label, and there's specs, the ports, which port we are dealing with. So the service itself will be running on port 8000 when it's created. And then it forwards the traffic to port 80, and that is the port number the service is actually running on inside the container or pod. So we hit the service 8000, and it automatically forwards a request to port 80. And then select there what pods will be included in this. Again, Web API service or any pod that has this label will be part of this service. And the type is node port. So node port would allow us to hit the service from outside the cluster. So let's go ahead now apply on line 63, apply on kubectl, apply -f and the name of our YAML file. So when you run this, we'll see that you get the results that the service and the deployment have been created. And we can verify that on line 66, kubectl, get pods -oy. So -oy basically means gives us more information about the pods, such as IP addresses. So we'll see that one of them has already been created. So this is the pod which is now, you'll see that one is scheduled on Windows Node 1, and then the other one is being scheduled on Windows Node 2. And as you can see, one of them is already created and running on the first one, and then the second one is being created. So sometimes for Windows, it takes a little bit time to create the containers because containers seems to be, at least for now, seems to be larger than the Linux counterpart. So you have to be a little bit patient. So let's go ahead and run that again. And as you can see now, they are both running. So that's a good sign. So these are the IP addresses of each one of those pods that was created. And again, one is scheduled on first server and the other one on second server. So as you can see now, like Linux, now we have achieved load balancing on our in our cluster for Windows as well. We can also take a look at our service, line 69, kubectl get services when we run this. So we'll see that now. So hello world, this is a Linux application, Linux-based application or Java-based application that are created called Hello World that we're going to use it to test our services, or .NET services is calling the services from that. And then this is the node port. So this is the Web API service. This is our .NET service. And it's running on, the service is listening on port 8000. If you remember, that is our service port. And then that forwards a request to a port 80, which inside the pod, so the application is actually running on port 80. So that's kind of redirection. Okay. So on line 72, we can now do some testing. First of all, let me just go ahead and grab this cluster IP. Just copy that. And then substitute here. So it's going to test the application service by running it from, so this is the cluster IP, and this is the port 8000. So let's go ahead and test the application. And sometimes it takes a couple of seconds for the application to start. And as you can see now, we get the results back. And this is actually the payload here this is the name of the pod, and this is the IP address of the pod that is running. We can also hit the service with node port. That is if you're calling the service from outside the cluster. So let's go ahead and grab the port. So this is a node port for the service. Go ahead and substitute that. And let me clear this. And so on line 75, let's go ahead and execute that and get the same result as we did before. So everything looks good, at least from hitting it from the node itself. Now let's do the real test, and that is calling the service from another pod inside the cluster, because that's the whole point. Mostly we want to make the service available, obviously, to all the pods that are running inside our cluster, and that is through a node port, through cluster IP. So on line 78, Cube CTL exec minus IT. So this is the pod. This is our Java application service that is running, and that's a pod name. And then we're going to SSH. So let's go ahead and SSH into that. And then we can run the same thing as we did here. So let's go ahead and run that. As you can see now, we get the same result, which is the name of the pod and the IP address. So this is good sign. So we are now able to hit the service, the Java service or any .NET or Java service, and we can consume all our services within our cluster. And that was the problem that we had when I evaluated the Flannel and Windows. We had a problem because we couldn't connect through the cluster IP from any other pod, but that limitation is now gone with you switching to Calico. So Calico, in my opinion, has done a better job of, at least for now, at this moment, of enabling adding Windows support to Kubernetes. So this is all good, but there's still some limitation. So let's go ahead and switch to our Linux node. And then let's try the connecting through the cluster IP first. If we hit that, so we are now running this on our master. So we run that. You'll see that it just waits and eventually it times out. So one of the issues right now with this, the Calico, is we cannot hit the service from the node, it has to be on the same node. So if you're like on a Linux node, you won't be able to hit the service using the cluster IP. But this is not really a big deal because you're not really hitting, you're not going to consume that most likely from our master. We're going to, or the Linux node, we're going to consume that from inside a pod, and that pod could be any pod, and the pod could be hosted on Linux, and no problem there. As we saw, we were able to call the service. But from hitting the service directly or the node or the cluster IP, we were not able to hit it from Linux node. So that's, but we should be able to hit that from hitting the node port. So let's go ahead and try that. And you can see the node port, no problem. So even we are hitting this is the IP address of a Windows server, we are able to hit that with the node port. Okay, we run this again now, and now we see that it's created. So far, so these are the two pods that were part of our deployment. I also created a Hello World application and deployed it to to the cluster, and that is the one that we'll be using testing. So we'll be calling the service from inside that, that pod. So we can also take a look at our services. And again, these are the service that we just created is Web API service. And these are the information. This is the cluster IP, and this is the node port. Now we can test the service if we add the cluster IP. So I just copy this and we add it here. And remember, the port was 8000. So this is the curl, and this is the cluster IP and port number. And we get the results. So this is basically our simple application, which basically returns the name of the service as the name of the pod or container that it's running on, and the IP address. So that's a simple Web API service. We can also connect to the service from outside. So let's go ahead and again run the service. And I am going to grab the port, the node port. And we can hit it from any node. So this is, I'm hitting it from one of the windows. This is the IP address of one of the windows, actually the same service that you're running on, the server that we're running on. So we run this, we get the same results. So now we confirm that the service is running fine. So important thing is we want to make sure that we can hit the service from a pod, because the whole purpose of creating the services obviously is to be able to call them from inside another service that is running in a pod. So on line 78, kubectl exec -it, and this is the name of our service that is installed on Linux. So we can sh into that, and then we can again do the same thing, hit it from here, so curl, and then the cluster IP and port number. So we hit that. So we get the same thing. We get the pod name and the IP address. You can also access the same information hitting by hitting the IP address of one of the servers and the port, node port. So we get the same result. So last test we want to do is connect to another Windows node and run some of the commands from there. So let's go ahead and SSH to the other Windows node. And let's see if we can hit the service using the cluster IP. So let's run that. As you can see now from Windows node, we are able to hit the service using the node, the cluster IP, and we can do the same thing, hitting the service using the node port. So on line 75, let's go ahead and run that. And as you can see now, we get the results back. So next, we're going to summarize what we learned and what are the limitations with Calico. Thoughts on the hybrid Kubernetes cluster that is consisting of both Windows and Linux nodes. Although Kubernetes Windows nodes are supported, this is work in progress. You have to understand that. It has its shortcomings, but I'm sure over time those will be ironed out. Please take a look at Intro to Windows Support in Kubernetes on Kubernetes site. I provided a link in that description for this demo, for this video. Please take a look at it, especially if you want to implement this in production, understand what the limitations are. One of the biggest limitations, in my opinion, right now is that Windows host OS mask exactly match the container version OS it is hosting. So there is a Hyper-V isolation support in the roadmap, but it's not implemented yet. So you want to make sure that all your Windows worker nodes exactly match the container that you will be deploying on, the same OS. For this demo, make sure you use Windows 2019 version 2004. If you have a mix of Windows and Linux worker nodes, ensure to set the node selector when you're creating your deployment. If you're doing for Windows, for node selector, you have to specify kubernetes.io/os:windows. And for Linux, you want to make sure that you add the node selector to kubernetes-io/os Linux. If you don't do that, then you get into trouble because Kubernetes start scheduling these pods blindly, and it will try to, for instance, schedule a Windows pod on Linux. So I mentioned that during the demo also, but you just make sure that you remember this when you are setting up your cluster and you want to test it. So that's it for this video. I hope you enjoyed it. If you have any questions, put it in the description. Also, if you haven't subscribed, please consider doing so, and also check out my other videos. Thank you very much.